Hey, good evening, Math 2 crew. It's 8 o'clock, and I'm going to be working on this practice assignment. It's page 374, all the odd questions, section 7.1. Remember, our goal is to find the greatest common factor of two monomials. So we have a pair of monomials, and our job is to find the greatest common factor. And that's our goal for this lesson. How do you find the greatest common factor? And so, several ways of doing this. Break this up in two parts. Okay, the first part was expand each of the monomials by using prime factorization. So, if you look at number 3, to break that down into its prime factors, the number 3 is 3 times 1. No big deal there, right? E would be broken down as E times E times E times E. And this represents the prime factor form of 3e to the 5th. Okay? Now, 9e squared, the prime factor form of 9 is 3 times 3. Right? And so, let's write that down. It's 3 times 3. And e squared is E times E. Now, for those of you who are still having trouble following along, a couple of things I want you to notice. And it's very important that you see this. The power has an exponent of 5. And so we had to write E 5 times. And you'll notice that I only wrote it how many times? 4. And so that would be an error. And so I would have to squeeze an E in here somewhere, and I'll do that. So there we go. It's okay to make mistakes. It's okay to make errors. Just catch them, okay? So that's the 5th power. E to the 2nd, 2 factors of E. And so this method of writing it out, expanding it, and looking at all the factors is long and tedious, but it works. And so now we box or circle the pairs of common factors. 3 is a common factor, right? And, of course, E. This box is going to be slightly angled. Common factor. And so is E here. Those are my common factors. So the greatest common factor of 3e to the 5th power and 9e squared, the GCF, is found by looking at these pairs. So we have 1 pair of 3's and 2 pairs of e's. Okay. And when you multiply that through, find the product, the answer is 3e squared. Now that's one technique. The other method, a little different, very effective, says that you only look at the coefficients of the powers. So just look at 3 and just look at 9 and leave the powers alone. And so 3e to the 5th would be written as 3. And again, I'm not going to write 1. 3 times 1 is 3 times e to the 5th. And then look at the coefficient of 9 and leave the power alone. Actually, let me rewrite that. I don't like the way I did that. Sorry. And so we did not factor our powers. Okay? And so now, pair up the common factors. 3e. So that's 1 pair. And then the next step says, identify the lowest power between the common variables. So these are my common variables. What's the lowest power? This one. The exponent is 2. And so the power that you choose for your GCF. And that's your answer. So compare common factors, bring down the pair, look at your powers, and then choose the lowest power. Write that down as your GCF. 3e squared, 3e squared. So hopefully that made sense. Now let's pick up the pace here. So let's use the technique of comparing our coefficients. Okay. Do they have any common factors? This is 7 and 1. This is 4 and 2, 2, 2. There are no common factors between 7 and 8. No common factors, right? And so that could be a problem. Now, let me just rewrite this again, guys. I'm sorry. I'm making some sloppy assumptions here. So the coefficients don't have anything in common. 7, 2, and 2, nothing in common. But now the variables. We have m squared and p. I forgot the p. Okay. So it looks like we have a common variable, p. All right. And so the common variable, which one has the lowest power? Of course, p does. P to the first, right? And so my GCF is just p. Now, I mangled that question. Just started off wrong, but that's okay. I'm going to keep pushing forward and attempt to clarify some more of these questions. So number 5. So let's take that. Let's write each one down. And so I notice that none of these factors have anything in common. 5, 2, and 3, no. H, S, K, and T, they have nothing in common other than a factor of 1 because it doesn't change your product. So my GCF is 1. These monomials would be called relatively prime to each other. Find the GCF of each set of monomials. Alrighty. So instead of rewriting all this, I'm just going to highlight that each of these sets has y in common, and each of these sets have x in common. And so now let's identify the lowest power in terms of exponent in each of the sets. So we're looking at the y's, the y variable. The lowest power, looking at the x variables, that's the lowest power. So your GCF, your greatest common factor, would be x to the third, y to the third. Okay? Next question. Same idea. I'm going to break this down. 2 and 5. 20. 4 times 5, which is 2 times 2 times 5. And 15 is 3 times 5. Okay? So what do each of these have in common? 5. So the coefficient common factor is 5 so far, because it's found in all 3 of the monomials. So I know I have 5. Now let's look at our variables. What do they have in common? Let's see. Wow, it might not be anything. We've got C in 2, but not in 3. D, nope, not in 3. And E's in 2. So we don't have any common variables. They're in 2 of the monomials, but not in all 3. So there are no common variables. So the greatest common factor is just 5. Yeah, variables are all, they're not found in each of the 3 monomials. That's our answer. A blank page. Next one is 11. I'm going to enlarge it. So again, the same technique. I'm just going to look at 4. Break that down. 2 times 2. 8 is 2 times 2 times 2. 5 is 5 times 1, or just 5. And 6 is 2 times 3. So the factors don't have anything in common. All of the monomials, there's 1, 2, 3, 4 of them, all have to have the same common factor. And 2, 2, 2, but 5 does not have 2. So we don't have a greatest common factor for the coefficients. Now, let's look at our variables and see if there's anything common there. G squared, G, F and H, G to the third. Nope. Let's look at H. H, nope. This doesn't have an H. G, F, nope. So the variables are not all found in each of the monomials. We have groups of 2 and groups of 3, but not groups of 4 with the same variable. So literally there's nothing in common here. So the GCF is 1. These are relatively prime to one another. Okay, find the GCF of each pair of expressions. All right, so this might seem a little more challenging, but it's not. And so by looking at this expression, what we see is that 2 and 5 have nothing in common. Okay? But I do see here this other term, this other factor. They have something in common. They're both the quantity y minus 3. And so this has a power of 4, this has a power of 5. And so we always choose the factor with the lowest power. So the GCF is y minus 3 to the 4th power. Moving on. Okay, now let's look at 8 and 6. Okay, first factors, 8 and 6, what do they have in common? Well, let's think about it. 8 is 2 times 2 times 2. 6 is 2 times 3, right? So what do they have in common? A 2. So I know that my GCF is 2. Now, what about the other part, the x plus 2? Well, which one of these has the lowest power? And that would be 3, right? And so it's 2 times the quantity c plus 2 to the 3rd power. That would be my GCF. Number 10, find the GCF of each set of expressions. Same kind of situation. We're looking at 5, 7, and 6. 5, 7, and 6 have nothing in common in terms of factors. They're all different. And then you'll notice that all 3 of the binomials here are different. This is s plus 5. This is x plus 5. It's different. Different variable. And here I have an s plus 5, which is fine, but it's not found in all 3 of the monomials. Remember, a GCF, a greatest common factor, has to be common in all of your monomials, and it's not. So there's nothing in common here. The GCF would be 1. Okay? Last question. Yes. I'm losing my voice. Okay, great. So I like what I see here so far. 6 is 3 times 2. I'm going to go in least to greatest. 2 times 3. 16 is 4 times 4, which is 2 times 2 times 2 times 2, right? 8 is 2 times 2 times 2. And so, what do we have in common here? We just have a 2. 1, 2 in each. Now, if we take a peek at our variables, a little more interesting here. Z plus 3, Z plus 3, Z plus 3. Which one has the lowest power? Third exponent, Z plus 3 raised to the third power. So that would be our part of our GCF. And so our GCF is, here we have 1, 2, found in all three monomials. And then Z plus 3, the quantity Z plus 3, raised to the third power. And ladies and gentlemen, thank you for listening. I hope it was helpful. And like I always say, study hard and learn a lot. We'll see you tomorrow. Bye-bye.